So today we're doing section 12.2. It's called Angles and Angle Measures. This is a lot of definition type stuff, but this is the foundation of what we need for trig. So understanding this information is extremely important. If this section falls apart, it kind of messes you up for the whole rest of the chapter. So what we're doing right here is the base of what we need to be successful moving forward. So if you have questions, of course, as always, make sure you guys ask. All right, so I gave a worksheet out with this lesson. If you printed it or have it, then you can just do it on that worksheet if you printed it out. If not, you would just take these notes in your notebook. So here we go. So I'm going to walk through these vocabulary words, and as we do that, we'll draw a picture. So the first one says, an angle is in standard position if the vertex is at the origin and one ray is on the positive x-axis. Okay, so just working on that bullet point. An angle. So let's just say we're drawing an angle of 120 degrees, okay? The vertex of that angle should always be at the origin, and we're always going to draw our angles in standard position, okay? One ray is on the positive x-axis. So the positive x-axis, here's our x-axis. The positive x-axis is this one. So you would draw your ray, see how that's a ray? Draw your ray on the positive x-axis. That always happens. This piece that I just drew, this ray, is the initial side. The initial side of the angle is the ray that's on the x-axis, right? Specifically that positive x-axis. All right, then the other is going to be the terminal side. Now, we just said we're going to draw 120 degrees, right? So this right here, where where I drew the x-axis on that positive initial side, this is 0 degrees, right? And then this would be 90 degrees, 180 degrees. This would be 270 down here. And then back again, this is 360. So this area right here has two angle measures, 0 and 360. All right, so if I want to draw 120, I start from the initial side, and I keep drawing an arc until I hit where 120 would be. So there's 90. So 120 would probably be right around here, okay? So that's how big the arc is going to be. And then I'm going to draw my terminal side. So the terminal side is a ray, right? And that would be my 120 degrees. Right, now it's really important that you draw this arc. This way you know that this is the angle we're talking about instead of like this angle out here, which has a different angle measure. All right, so always draw that arc so we know which angle you're talking about. Right, the angle of rotation, the fourth bullet point here, the angle of rotation is formed by rotating the terminal side and keeping the initial side in place. So that's basically what we did right here, this arc, right? That's the angle of rotation. So we start on the initial side, and then we go to that terminal side, right? This is a positive rotation, right? Positive rotation, we went counterclockwise. So we started at the initial side, went counterclockwise. This is a positive rotation. A negative rotation, I'll do one over here. A negative rotation would go the other way. So let's say we're going to do, we're going to graph negative 45 degrees. So our initial side is here on the positive x-axis, always. I'm going to rotate clockwise, which is this way, negative 45 degrees. And then put in my terminal side. Think terminal like terminate, like right, it's the end. So initial side, terminal side. And I have that arc there, right? Again, that arc is really important because if I don't have that arc there, right, if my diagram just looks like this, and I say, you know, how many degrees is this angle? You don't know if I'm talking about this angle here or this big angle here. So it makes a big difference. So we draw that arc there so we know which angle we're talking about. and then we know it's negative 45 degrees. There's a diagram in your book that looks something similar to this. It's not the exact same picture, but again, just notice it has that initial side, the terminal side, that arc. So this angle was 135 degrees. Something I forgot to mention on the previous slide, the angle measures, if you're doing a negative rotation, it starts at 0, and then you're rotating this way, so this would be negative 90 degrees, negative 180 degrees, negative 270 degrees, and then back to negative 360 degrees. So if you notice, when we draw a coordinate plane, this location up here has multiple names, right? This location up here could be 90 degrees. It also could be negative 270 degrees, and it actually has an infinite amount of other names, which we'll talk about coming up, right? So just know that one location could have multiple labels to it depending on what you're talking about. So that's how you draw an angle. So either in your notebook or if you printed the worksheet, use that. I want you to draw these 3 angles. So you can pause the video, try to do that. Make sure you draw your arcs, pay attention to your terminal side and your initial side. Go for it. Okay, so these should be what your drawings look like. Okay, again, make sure you just use a different color. Make sure you like really darken so we can see that initial side. There's your terminal side, and you've got that arc. You don't need this little arrow here at the end of the arc. Sometimes people put it, sometimes they don't. It's totally up to you. For negative 110, here's that initial side. Here's the terminal side, and there's our arc. Again, if you don't want that little arrow, you don't need it. This one, the book doesn't, the diagram I have on the screen right now doesn't do a great job of showing the initial and terminal sides. Here's the initial side, okay? Then here's where the arc starts right here. It goes around one time for 360, and then it takes another loop. And this is how you should draw it. Oops, sorry, that's really bad. Right? You should draw it with this like spiral effect. So you make full 2 rotations and then around again to here. We want to draw that terminal side, right? Really bold it. Right? So if you're doing this on paper, you really want to bold your initial side and your terminal side. And this should be this spiral should be one continuous spiral. Like, don't lift your pencil. Okay? All right, so that's how you draw angles. Coterminal angles. Oh, sorry, one more thing I forgot to mention back here. This diagram here is special. We call, not because it rotates multiple times, but because it's what we call a quadrantal angle, right? Because if I asked you, like, what quadrant is the terminal side in, right? In this diagram, this first one, what quadrant is the terminal side in, right? This is quadrant 1, 2, 3, and this is quadrant 4. So the terminal side here is in quadrant 4. For the middle diagram, where is the terminal side, right? Quadrant 1, quadrant 2, it's in quadrant 3. But for the last diagram, if I ask you where is the where is the terminal side? It's not really in a quadrant, right? It's on the axis. So therefore we call it a quadrantal angle. So when the terminal side coincides with one of the axes, right? It could be any of them, the x-axis, the y-axis, any of the axes. Okay, oops. So coterminal angles, right? Coterminal, think prefix co and then terminal. Terminal is referring to the terminal side of the angle. Co means that they share it. So they share the terminal side. So if we have let's just draw 30 degrees. So here's my initial side. Here's my terminal side. Right, this is 30 degrees. I want to draw another angle that shares that same terminal side, okay? But it can't be 30 degrees. So I'm going to draw another angle right on top of it. So here's the initial side. If I go around a full rotation and then stop at that same terminal side, right? These are, the green and the red are coterminal angles. They share the same terminal side. What's the measure of that green angle? It was 30 and then a full rotation all the way around. So we can say it was the 30 degrees from the red plus a full rotation. So plus 360. So that green angle there is 390. So I would say that 30 degrees and 390 degrees are coterminal angles. They are angles that share the same coterminal side, right? We also could have gone the other direction. So we could have started at the initial side and gone in a negative direction, gone clockwise, and gotten the same terminal side. That would have given us a negative angle, 330. Here, I'll draw it. So my original color was red, right? This was the 30 degrees. So now if I want to do, let's go with purple. So if I want another angle that's coterminal, right, that's a negative angle, I could draw the same initial side, but this time I'm going to go clockwise in the negative direction. I'm going to stop at the same terminal side, right? So what's the measure of this purple angle? Negative 330 degrees, right? Mathematically, how do we get that? It would be 30, but then we go 360 in the other direction, and that gets us negative 330 degrees. So negative 330, 390, and 30, all three of these angles are what we consider coterminal, right? So how do we find coterminal angles? Right, here's 65. The directions usually say find a positive coterminal angle and find a negative coterminal angle of 65. So how do we do that without drawing a picture and visualizing it? We take our angle. To find a positive angle, we add 360 degrees. And that gets us 425. Right? So 425 is a positive coterminal angle. To get a negative coterminal angle, we would take 365 and subtract 360 from it, negative 295. Now there are an infinite number of coterminal angles, right? Infinite. These are not the only two coterminal angles to 65. There are an infinite. What we can do is keep adding or subtracting multiples of 360. So I could have added 65 plus 720, right? That's two full rotations away from 65. That would get me 785. So there's another one. Now, on my answer sheet, I usually put the first largest and the first like negative one that you get. So if you're checking an answer sheet, you might not see 785 on it, but just know that you're right. You just can check with me if you're not sure, right? We also could have done like 65 minus 720 degrees, and that's a negative 655. Okay, so when you're finding coterminal angles, if it says find any positive or negative coterminal angle, just know that your answer might not be exactly the same as the answer sheet, but you might be right. So always check if you're not sure. So if you want to pause and do 410 and negative 120. Find a positive coterminal angle and a negative coterminal angle for each one. All right, so for 410, the answers that I have are 770 and negative 310. Right? To get these, I took 410 and added 360 to get 770. And I took 410 and subtracted 360 to get negative 310. Other popular answers here, which are perfect, would be 50 degrees, because if you take 410 and subtract 360 from it, you get that answer, right? That's a positive angle. So your two answers then would be 50 and negative 310, right? It is, make sure that you don't give these two as a final answer, right? 770 and 50, especially if the directions ask for a positive and a negative, right? So you could have 770 and negative 310, or you could have 50 and negative 310. Another answer I sometimes get is negative 670. So if that was one of your negatives, you're good. For negative 120 degrees, these are the most popular answers I get. Right, a positive and a negative coterminal angle. If you had 600 and negative 840, those are also correct, right? So key takeaway here, add 360, subtract 360 to get coterminal angles as many times as you want to. You can keep adding 360, 360, 360, 360, and there's an infinite number of coterminal angles. Okay, the last part of this lesson is converting between degrees and radians. So in the book, it gives you like what is a radian, and there's an explanation to what that is. You can go and read that if you would like to. What you need to know is that a radian is basically a measure for theta. Just like, if we're measuring distance, we can use feet, we can use meters, we can use miles, right? We have all these different units. If we're measuring an angle, you typically will use degrees, or you can use radians, right? The symbol, the unit symbol for degrees is the degree symbol. There is no symbol for radians. It's the word radians. Typically, people will leave off the word radians, though. You just give your answer as, 4 pi. And we just know that that's in radians because there's no degree symbol, right? So the pi is usually, the indicator that it's radians. It's not typical to write the word, okay? So to go from degrees to radians, you want to either copy this down or put it on your worksheet. To go from degrees to radians, you're going to multiply, sorry about that. You're going to multiply by pi radians over 180. To go from radians to degrees, it's the other way around. So 180 degrees is equal to pi radians. So we can use this ratio either way, depending on what we want to convert to. A lot of students try to memorize, like, degrees to radians, it has to be this way. And radians to degrees, it has to be this way. I just look at the units and see what makes sense. Let me show you what I mean. Okay. So if you're converting from 2 pi over 3 radians and you want to convert it to degrees, right? I'm going to leave off the radians for right now. You need to multiply, right? And you're going to multiply by either 180 over pi or pi over 180, right? And a lot of people memorize which one to use when. I just say look at the symbols, right? You want the pi's to cancel if you're going to convert into degrees, right? You want the degrees to be on top and you want the pi's to cancel. So I would want the pi to be down here so that the pi's can cancel and the 180 degrees goes up there. Now, note that this would be a no calculator question, right? And actually probably the same with this slide, find all the coterminal angles, that would be no calculator. I know you guys can handle it, right? So 2 pi over 3 times 180 over pi, those pi's would cancel. And then we just did a whole unit on multiplying these rational values. you would do 2/3 times 180. So you could either cross cancel the 3 and the 180, or you could multiply across, which is what I recommend. 2 times 180 is 360 degrees divided by 3. Simplify that. The answer is 120 degrees, right? For 4 pi radians, again, same thing. Oops. You're going to do 4 pi and multiply it by that ratio. The pi's cancel. 4 times 180, 720 degrees. Don't forget the degree symbol on your answers. All right, let's go the other way. So if you're given something in degrees and you want to go to radians, right, again, you know you need to multiply by that ratio. The question is just which way, which one goes where. You want the degree symbols to cancel, which means you need that degree to be on the bottom so it cancels with that degree on the top. So that's your setup. All right, so you can go ahead and try this one and the next one if you want to pause, and then come back, you'll see the answer. All right, so you'll see here, this was a copy from a textbook. These are the final answers. You do not have to put the word radians on your answer. So I would just write negative pi over 3, and I would write 4 pi over 9. It is not normal to write negative 1/3 pi. It's not wrong, it's just not normal, right? Same thing here, 4/9 pi. That's not typically how you write your radians, right? So these two boxes are what you want. Now, name a positive and negative coterminal angle to each of these angles in radians. It's a little confusing of a sentence there, but what I'm asking you is, the first answer there was negative pi over 3 radians. Give me a positive coterminal angle and a negative coterminal angle of this, but in radians. So when we were doing degrees, we added a full rotation, right? We added 360 degrees and then subtracted 360 degrees, right, to get our two coterminal angles. So the question is, what's the equivalent of 360 degrees in radians? So think about that, pause, see if you can get an answer. And it should be, you're adding 2 pi. So 360 degrees is equal to 2 pi. So when you want to find a coterminal angle in radians, instead of adding 360 and subtracting 360, you're going to add 2 pi and subtract 2 pi. So again, no calculator, so you're going to need to get a common denominator. So I'll just do one for you here. So if I'm doing negative pi over 3 plus 2 pi, you need a common denominator. So I would do something like this. I would change this, multiply by 3, multiply by 3. So then add my numerators, negative 1 pi plus 6 pi is 5 pi. Keep the denominator the same. So that's my positive coterminal angle, right? You can do the same thing for negative pi over 3 minus 2 pi, and you can get negative 7 pi over 3. Right? So pause the video and see if you can get a positive and negative coterminal angle for 4 pi over 9. A positive coterminal and a negative coterminal for 4 pi over 9 using radians. Right? And you should be getting 22 pi over 9 and negative 14 pi over 9 for your coterminal angles. One positive, one negative. Again, there's an infinite number of answers, so if you had another answer, you would need to check it with me. This diagram is in your book. I'm not sure on what page. It just shows we call this the unit circle. We'll get to that another day. But it shows you all the degree measures here on the inside of the circle. So 0, 30, 45, 60, 90, right? It's going in a positive direction. It goes all the way around. It's also showing on the outside the radian measures. So 0, pi over 6, pi over 4, pi over 3, pi over 2. I I highly recommend, and it says it right here, memorizing these important values. So, and I would also memorize like that pi is equal to 180. I would memorize this one, that 270 is equal to 3 pi over 2. I would memorize that 2 pi is equal to 360, right? All these right here, these are important. We use them a lot. We mostly work in degrees in this class. Next year in pre-calc, you mostly work in radians. So we will convert back and forth this year, but it is helpful to start learning them. What's easy is if you know this first quadrant here, right? If you know this first quadrant, you can figure out other ones. So if I wanted to know, for some reason, I wanted to know 240, right? And I want to know how many radians that was. You could say, okay, well, 240 is 60 multiplied by 4, right? So if you know that 60 is pi over 3, right? If you know that value off the top of your head, you can say, oh, if I just multiply that by 4, I get 4 pi over 3. So that's how that could work to your advantage. It skips the whole converting from degrees to radians by multiplying the way we just did in the previous slide. And it just gets you there a little bit faster, which is always an advantage. All right, so check Google Classroom for your homework. And here is our joke of the day. I wish I could be there with you for this one. What do you call a math teacher who takes his vacations at the beach? A tangent. I know you're all laughing at home. I sure hope you are. All right, check Google Classroom for your assignments, and I'll see you guys later.